Hello everyone, welcome to my YouTube channel Know About Embedded Systems. So in today's video we will explore some more interview questions on embedded system. So please do not skip this video, watch till the end to get some more interview questions on very important interview questions on embedded system. So before starting the video, if you are a new viewer to my channel, kindly subscribe my YouTube channel, share these videos to your friends and colleagues and click on like button. Let us start the video. So one of the important question in the interview is write an embedded C code to toggle the LEDs via GPIO. So we're supposed to develop the code for GPIO toggling LEDs and we have to show it in front of the interviewer on the notepad. Very simple code it is. It looks like this. So usually the controller to controller registers will vary here. But for my understanding, for my programming, I have considered here LPC176 microcontroller. Using that, we try to develop the simple code here to toggle the LED. The first instruction, you can see this is your main and this is your inclusion, header file inclusion. And then I have here direction configuration. So LPC underscore GPIO 0 FIO DIR. This is the register we're going to configure as a like input and output direction. So currently when I use the FF, the 8 bits which are starting from 0.0 to 0.7, 0.0 to 0.7 configure will be configured as an output port. Okay, so this is the first statement, and second thing is we're going to set it. You can see here LPC GPIO FIO set. FIO set is a register which is used to set the bits to high. Again, I'm using FF here, 8 bits. I'm considering 0.0 to 0.7. Similar to that, I'm going to consider one more register, FIO clear FF. It will clear 0.0 to 0.7. In between, I'm using a delay here, approximately 100 millisecond delay I'm using here. Okay, so this is a simple code. You need to type it on the notepad during the interview. For the interviewer, you have to write it and you have to show them and to try to explain what are the registers and how they are working. I hope this is clear. This is the most expected programming question, especially for embedded C. The second important question is like a sixth important question. It's not a second one. Write an embedded C code to generate the software delay. Usually in our microcontroller programming, we will use two types of delay. One will be hardware delay and one will be software delay. Hardware delay can be generated from the timer that I'll be explaining later. But one more thing is called as a software delay. Software delays are generated by using one or two for loops like this. Using a nested for loop we'll be using. So approximately this is also going to generate 100 millisecond delay. So I'm using one for loop for 100 using I, and one for loop I'm using J up to 5000. So it is going to execute 100 into 5000 times, approximately 100 millisecond it's going to generate. So next very important question you can expect in the interview is, what do you mean by infinite loop and why it is used, and how to construct infinite loop. So in infinite loop is nothing but always it's going to be continuous execution is called as an infinite loop. A never-ending loop is called as an infinite loop. There are two ways in our embedded system we can design the infinite loop. One is using for loop and one is using a while loop. So for semicolon and put it in a braces, so this will become an infinite loop, and while of one curly braces open and close, this will also become infinite loop. So why this infinite loop is required? Now let us see in our embedded systems. So infinite loop in an embedded system is deliberately constructed never-ending programming loop. This I already told, it's a never-ending loop. So this will keep your processor running code continuously until power is removed or reset occurs. That means inside this while of one, if you write a code, the code will be continuously executing. So why this is required? You can see the reasons here. In embedded system, we required inputs to be monitored continuously. So loops to monitor the inputs continuously. Sometimes we have to update the outputs. Sometimes we have to maintain the functionality continuously. In order to achieve these three important things, we are going to use infinite loop, and code will be executing inside this infinite loop. So real-time examples, if you observe, so one is a washing machine monitoring different sensors in a washing machine, managing traffic lights, and operating monitoring the heartbeat and monitoring the vehicle speed in a real-time scenarios. So these type of applications, we have to read data continuously, we have to update data continuously. This is possible only using infinite loop construction. I hope you are clear with this. So the next one more important question what you can expect in the embedded system interviews is, what is an interrupt and how interrupt works? This is a very important question you can expect in the interview. So basically, what is an interrupt? Interrupt is nothing but it is a signal which is generated either from the software or hardware whenever whenever your devices require a service from the CPU. So basically, interrupt is nothing but it's a signal generated by software or hardware. So whenever interrupt occurs, so this is the flow that I'll be explaining now. So now we will try to understand the definition here. What do you mean by interrupt? Interrupt is a signal in a microcontroller which can be generated either from a software or a hardware. Like example, like a timer. Interrupts can be generated from timer. Interrupts can be generated from ADC or UART whenever they require a service from the CPU. So this is the definition of an interrupt. So interrupt is nothing but it is a signal which are generated from either from the software or from the hardware. Example like ADC, timer, UART, whenever they require a service from the CPU. So that means whenever they require ADC, timer or a software, whenever they require a service, they will send one signal. That signal is called as an interrupt to the CPU. Okay, so now how the interrupts will work in a simpler way, we'll try to understand. So let us assume my CPU is executing a main program here, but in the middle I got an interrupt. So whenever you got an interrupt from various sources, so what the processor will do, processor will pause your main program. So as soon the CPU notices the interrupt, CPU will suspend the main program temporarily. The main program will be halted. Okay, so the main program will be halted and starts executing the special program called as interrupt service routine. Now, whenever there is an interrupt, the main program will stop executing and it will store some of the basic important information in the stack, and it will go to the vector table. From the vector table, it will take the interrupt service routine address, and later your processor will jump to interrupt service routine, and then it will execute ISR. Again, context restore will happen. Again, it will resume back to the main program. So after successful execution of ISR program, processor will resume main program where it got an interrupt. So if you explain this much with the so with the this concept, that will be more than enough to understand the interrupts. I hope this is also clear. So one more important question, what you can expect in the embedded system interview is, what is a polling in embedded system and why it is required? Okay, so for the answer for this question, the polling is nothing but continuous monitoring of certain applications, certain functionalities, or certain hardware mechanisms or hardware functionalities, or monitoring continuously of particular peripheral is called as a polling. So what CPU will do? CPU will continuously monitor one particular function. If it is set, then only it will go and execute some other instruction, or else it will be continuously monitoring. Is called as a polling. Now we'll see the definition here. The polling is a technique used in embedded system where the processor continuously checks the status of external device or a peripheral condition in an infinite loop. So this is your definition for a polling. So polling is a technique which is used in embedded system where the processor will continuously check the status of external device or any peripheral condition in an infinite loop. So that means you can see here, let us assume this is my processor, and this processor is continuously monitoring in an infinite loop. Check whether the condition set or not. If not, it will go again, it will go on monitor. So it will go on continuously. The processor will monitor that particular condition. If the condition is set, then it is going to execute some instructions or some piece of code. Again, it will go on monitor the same condition, or it may go to other condition as well. So this process of monitoring the particular hardware or a particular condition in an embedded system is called as polling. Okay, so example for polling is checking a done bit in a ADC. So in ADC we have something called as a done bit, nothing but a conversion completion bit is there. So we have to monitor that, then only the ADC result we will get in the result register. Okay, so that is a one example, and the second example is transmission completion flag. So whenever you are transmitting a data in protocols such as UART, SP, and I2C, we have to check whether transmission completed or not. If transmission is not completed, then processor will wait until completes the transmission. Okay, these these 3 to 4 examples you can give in the interview for the polling method. So one major drawback with the polling is it is a waste of time. The most of the time will be wasted in the monitoring only. If the condition is not met, then processor continuously it is going to waste its time just to monitor the particular condition or a particular bit. Okay, so this is called as polling. So one more important question what you can expect in the interview is write a simple code for a polling statement. Just we have discussed about polling, right? So in the similar way, usually in some interviews they're going to ask you write a small statement or write a one polling statement for monitoring one particular condition. So then you have to write its polling condition. So it goes like this. So this is what just now I have told you, done bit monitoring, right? So you can see here this in my ADC we have something called done bit. This will have one particular bit. Usually it is going to be 31 bit number 31 it is, and I'm going to check it in a either ADC status register you can check, or a global data register you can check it. Okay, so LPC ADC global data register perform AND operation with one particular bit, done bit, check whether it is 0 or not, is equal to 0. If this is 0, so do nothing. So this is called as a polling. If the done bit is 0, you be here only, do nothing. If the done bit is 0, do nothing. If done bit becomes 1, then you exit from this while of 1 and do some other part of the coding. It will exit from the while of 0, while of this condition. So then it is your processor will execute some other functionality. So this is a one example for a polling statement, and one more example also I can show you for a transmission completion flag. The same thing here. I'm going to monitor whether transmission completed or not. So LPC UART 0, LSR nothing but line status register, TX completion bit. If TX completion bit is 0, meaning that transmission is not completed. If TX completion bit is 1, then I can say that transmission is completed and you can exit from the polling, go to the next statement. So like this, you can use these two statements to show to the interviewer to show the polling statement. Okay, so I hope this video is clear. So if you feel this video is an informative video, so please click on like button, share this videos to your friends and colleagues, and subscribe my YouTube channel.